Hi everyone. In this video, we're going to talk about logarithmic differentiation. We most often use logarithmic differentiation when we have very tedious functions. If we were to use the product rule and quotient rule, chain rule, and power rule on this, it would turn into a very long calculation. So we can use logarithmic differentiation to simplify this. The first step is to take natural logarithms of both sides of this equation, but actually we're first going to write it in the form, we're going to replace the f of x with y, so it's a little bit easier. So we'll just rewrite this like this, x squared plus 4. Now what we'll do is we'll go ahead and take the natural log of both sides, and then we'll use the laws of the logarithms to simplify this. So we have natural log of y. I'm just going to take the natural log of that entire right-hand side, so that's x cubed minus 1 to the 4th. And actually what I'm going to do here is rewrite this so that it has, instead of the radical symbol, we'll have a power, 3x minus 1 to the 1/2. And then in the denominator, we'll have x squared plus 4. Now we're going to use the product rule for logarithms and also the quotient rule, and we'll split this up. So this will be the natural log of x cubed minus 1 to the 4th plus the natural log of 3x minus 1 to the 1/2 minus the natural log of the denominator, x squared plus 4. And finally, we'll use the power rule to bring these exponents down in front. 4 natural log of x cubed minus 1 plus 1/2 natural log of 3x minus 1 minus the natural log of x squared plus 4. And that's the fully expanded version using those laws of the logarithms. Okay, so now what we'll do is we'll take this and we'll differentiate both sides implicitly. So remember, y is implicitly a function of x. So when we take the derivative of this natural log of y, we'll first take the derivative of the outermost function, the natural log, which is 1 over y. And then we have to take the derivative of the y, which we'll just call y prime. We'll use the y prime notation. For the right-hand side, we'll just use the regular rules of differentiation. The constant multiple rule, the 4 will stay out. And then we'll have the derivative of the natural log of x cubed minus 1, which is 1 over x cubed minus 1. Using the chain rule, we take the derivative of the outer function, and then the inside function would be 3x squared. And we'll just apply this to these other terms. So we'll have plus 1/2 times 1 over 3x minus 1 times the derivative of that inside, which is 3, minus 1 over x squared plus 4 times 2x. And I can simplify this down. This will be 12x squared over x cubed minus 1 plus 3 over 2 times 3x minus 1 minus 2x over x squared plus 4. Okay, now I'm going to solve the resulting equation for f prime. So remember, that's synonymous with y prime. So we're going to solve for y prime, and the way we do that is we simply multiply both sides by y. So I will have y prime equals y times 12x squared over x cubed minus 1 plus 3 over, we'll just go ahead and distribute that 2, so it'll be 6x minus 2 minus 2x over x squared plus 4. And finally, we'll go ahead and replace that y prime with the f prime of x. And then we'll replace the y here with the original function, which is this x cubed minus 1 to the 4th. So we have x cubed minus 1 to the 4th times the square root of 3x minus 1 all over x squared plus 4. And then we'll multiply that by the rest of this, 12x squared over x cubed minus 1 plus 3 over 6x minus 2 minus 2x over x squared plus 4. And that's good enough. We don't need to simplify it any more than that. And that's our final answer. So that's how we use logarithmic differentiation. And it should, in general, be a little faster than going through all the rules, again, product, quotient, powers, and all that, to find that derivative. Okay, so let's go ahead and use that to try a few other problems. Let's use this one here. This one is not too difficult. We could probably use the product rule here, but let's go ahead and try it with logarithmic differentiation. Again, we'll start by replacing that f of x with y. So y equals x squared cosine of x. And then I'll take the natural log of both sides, natural log of x squared cosine of x. I'll use the product rule on the right-hand side, the product rule of logarithms. So that'll be the natural log of x squared plus the natural log of cosine of x. And then I'll go ahead and do the implicit differentiation. So that the derivative of natural log of y is 1 over y. Using the chain rule, I'd have to multiply that by the derivative of the inside, y prime. This becomes 1 over x squared times 2x. We'll simplify that in a minute. Plus 1 over cosine of x times the derivative of cosine of x, which is negative sine of x. Okay, let's go ahead and simplify this down a bit. This will be 2x over x squared is just 2 over x. And then this becomes minus the sine of x over cosine of x, which is minus the tangent of x. And now I'll go ahead and solve for y prime by multiplying the y on both sides. And I'll replace that f prime, that y prime with the f prime of x. So this becomes y times 2 over x minus tangent of x, which is just x squared cosine of x, the y. So x squared cosine of x times 2 over x minus tangent of x. In this case, maybe we can simplify it a little bit more. We'll go ahead and rewrite the tangent as the sine of x over the cosine of x. And then when we distribute, we'll go ahead and distribute this and simplify this out a bit. The x squared cosine of x, when we distribute it to the first term, one of these x's will cancel, leaving us with a 2x cosine of x. And then when we distribute to the second term, we'll have the cosines cancel, so we'll be left with x squared sine of x, which you should check will be the same as if we were to just use the product rule on this. Okay, so logarithmic differentiation can be used for these ordinary functions, and sometimes it may be less difficult than using the product rule, quotient rule, sometimes a little more difficult. So you just have to choose which one you think would be better, but you should get the same answer. Okay, this is a function that's a little more complicated. We would have to use a combination of product rule for differentiation, the quotient rule, the power rule, all those things. So fairly complex, lots of terms. So let's go ahead and use logarithmic differentiation. Again, we'll rewrite this, replacing the f of x with y, and then we'll write these terms with the exponents, x plus 7 to the 1/3 over x to the 4th times x squared plus 3 to the x. Now this one, we would definitely want to use logarithmic differentiation when we have this sort of x to the power of x. Okay, we'll see how that works. So let's go ahead and take the natural log of both sides. Again, using the product rule for logarithms, the quotient rule and the power rule, this is going to be 1/3 times the natural log of x plus 7 minus 4 times the natural log of x minus, we'll have a plus in here, but the minus sign from the quotient rule will distribute. So I'll have a minus x, that power comes out in front, times the natural log of x squared plus 3. Okay, so I skipped a few steps there. Hopefully you can follow along. Now we'll go ahead and do the derivative, do implicit differentiation 1 over y times y prime equals 1/3 times 1 over x plus 7 times 1. The derivative of x plus 7 is just 1, minus 4 over x times 1, minus, now I'm going to have to use the product rule here, but that should be okay, the derivative of the first is, so I'll put parentheses around this first. The derivative of the first term is 1 times the second natural log of x squared plus 3 plus the first times the derivative of the second, which is 1 over x squared plus 3. And using the chain rule, I have to multiply by 2x. Okay, let's go ahead and simplify. 1 over, I'll go ahead and distribute that 3x plus 21 minus 4 over x minus the natural log of x squared plus 3 minus 2x squared over x squared plus 3. Okay, and now I solve for the y prime, and again, I'll replace that with f prime y times 1 over 3x plus 21 minus 4x minus the natural log of x squared plus 3 minus 2x squared over x squared plus 3. And then finally, the last step is to replace the y with the original function. So cube root of x plus 7, cube root of x plus 7 over x to the 4th, x squared plus 3 to the x to the 4th, x squared plus 3 to the x times all of this, 1 over 3x plus 21 minus 4 over x minus the natural log of x squared plus 3 minus 2x squared over x squared plus 3. Okay, and that's our final answer. You don't need to simplify it any more than that. And that's it.